Let me demonstrate why this is so important. Let's pretend you have two spaces in this configuration with massive windows at each of the exposures. As the sun travels throughout the day, the foyer is going to peak in the morning and the great room is going to peak in the evening. Now, we don't have to pretend because this is an actual project, and I've already calculated the loads for these peaks. You'll see massive window area for these facades, and if I review the loads for the foyer, I'm going to see that peak in the morning happen around 10 a.m. and it peaks at 16,000 BTUs. So let's write that down. Now the great room is going to peak in the evening, and that peaks at 18,000 BTUs. Now let's say both of these spaces are on one zone, and we need to size equipment for that zone. Can we just take these peaks and add them together to get a zone total of 34,838 BTUs? No, because these conditions are not happening at the same time. So we need to take the coincident load of both of these spaces together, which is also called block load. I've zoned these spaces together so that we can see that in action. Here we can see that first peak in the morning, a dip, and then that second peak in the evening. The total load is not 34,800, it is 29,800, because those peaks are not happening at the same time. So if we need to size this unit, we're not going to use the sum of space peaks, we're going to use that coincident load that we calculated instead, 29,874 BTUs, which, if you're wondering, leads to a saving of 14.3%.